Everyone, in this video we are going to discuss about what is AI, what is ML, what is deep learning. So all the basic definitions and all we are going to discuss in this particular video. First of all, let's try to understand what AI is. So whenever this particular AI comes into our mind, we'll think like a machine exhibiting some kind of human behavior. So simply we can say this as our AI. Okay. So this is the simplest definition of AI, or we can say like machine mimicking human behavior. Anything we can say it as AI definition. Okay. Like in order to AI become so successful, there are three main possible reasons. So let's go through each one of the reasons. Okay. So first one can be like algorithms. Now we are having many advanced algorithms in case of deep learning. So we are having something like ANN, CNN, and RNN. And also we are having some recent architectures like transformers. And also in order to generate some images or doing like that, we have diffusion models like that. Now we are having different model architectures with which we are able to generate really good applications or really good use cases we are able to solve with the help of the algorithm that we are having. And along with the algorithm, we should be having large amount of data. Okay. So that we can call it as big data. So like if you are having good algorithms and not having data doesn't help us in any way in order to achieve the success that we have achieved today. So along with algorithms, we also need to have lots of amount of data. And now currently the amount of data that is generating is very high. So if I remember in around some 2014, I used to use 1 GB for a whole month. But now I'm using the same 1 GB within 1 hour. Okay. So that is the amount of data that is being generated today, right now. So if we observe like the amount of data that I'm consuming is directly proportional to amount of data that I'm generating. Okay. So now, as I said, within 1 hour, I'm consuming like 1 GB of data, right? So it is directly proportional to the amount of data that I'm giving or that I'm producing. Like, let's say I'm watching Instagram. So the kind of content that I watch will be a data to Instagram. And similarly, if I'm doing something on Facebook, what I'm doing on Facebook will be the data for Facebook. Okay. So like that, everything that I do on internet is in some sense data to some other big company. Okay. So with the help of this big data, we can implement or we can use this data in these algorithms and we can achieve the success that we are having. And along with these two, we also need to have something called as computational power. If we don't have computational power, then we can't like process the data that we are having, right? So along with algorithm and data, we also need to have computational power. And the CPUs or laptops that we are using is not at all sufficient in order to handle such big data and algorithms. That's why we need to have GPUs and also we need to use TPUs. Okay, when you are performing some very good or very highly resource taking tasks. Okay. So now we have gone through what are the main reasons for AI becoming this big. Now let's see some history of AI. Like the concept of AI got started in 1960s itself. So at the time of 1960s itself, they came up with this particular definition of AI and all. But like at that time, it is not very popular because, as we discussed just now, the main reasons are algorithm, data, and computational power, right? So at that time, we don't have data and we don't have computational power. We might be having some good algorithms, but with the help of, as these two are not there, we are not able to achieve anything. Okay. So that's why till 1990s, like whatever algorithms we are having, we are not able to achieve anything with those algorithms. Okay. But after 1990s, we are able to generate data somehow because of the emergence of internet and all. We are able to generate data. New algorithms also came up from this era. So, and actual growth of AI started from 2000s So after 2000s, we started using mobile phones. Okay. So when mobile phones got increased, the amount of data that we are generating got drastically increased. Okay. So as the data is increasing, it is helping us in order to build very good AI applications. Okay. And in around 2016 or 17, like Google came up with an architecture called as Transformer. And with the help of this architecture, so many other companies like OpenAI and Meta, all these companies have somehow integrated this transformer architecture in their LLMs and all, and they have built really good models. And also Google is also having LLMs. Okay. So now whatever you guys are saying, like ChatGPT and all those internal architecture is some modification to this transformer. Okay. So like that after 2016, now the current era is on generative AI. So you might be thinking, what is this generative AI? So in generative AI, we can think of ChatGPT. So ChatGPT is also kind of generative AI because there we are generating the text which is not even seen on the internet. So whichever things which are being newly generated by the machine, those we can consider under generative AI. So ChatGPT is a kind of generative AI which generate text. Okay. And similarly, there are some other text to image models like DALL-E, which is a like model built by OpenAI. And also there are some other image models like Imagen by Google and Stable Diffusion. Like that, there are so many text to image models. And recently, OpenAI has already launched something called as Sora, which is text to video model. All these models are being newly coming up daily. Okay. So recently they released this particular Sora. So like that, all these applications that we are seeing are possible only because of the amount of data and computational power that we are having right now. Okay. Now let's move on and see what ML is. So till now we have gone through what is AI and its applications. Now let's see what is ML. ML is some subpart of AI. So if we think AI is some big circle or AI is some very big domain, within AI we are having something called as ML. So ML is like we'll be having data. So from that particular data, we'll be extracting patterns out of it. And with the help of these patterns, we'll be able to predict future or predict the output on future points. Okay. So simply we can say it as ML. So in ML, what we will be having, we'll be having data and we have to extract patterns out of the data and we'll use those patterns or relation between the data. So what is data? We'll be having both input and output. So we'll extract the relation between those input and output and we'll try to predict the future output. Okay. So that we call it as ML. And within ML, there is subdomain that is called as deep learning. So what is ML? ML is machine learning and there is a subpart within ML that is deep learning. So with deep learning is also the same. Like there also will be having data and extracting patterns from that. But in case of deep learning, we'll be using something called as neural networks. Okay. See, these neural networks are very specific to deep learning, and that we'll be discussing in detail when we reach that particular topics. Okay. And that is about AI, ML, and deep learning. So let's see how traditional programming is different from machine learning. So if we see the traditional programming, like there will be machine, and for that machine, we'll be passing input, and along with the input, we'll be sending one program. Okay. So in this program, we'll be writing logic with the help of our intelligence. So that we'll be doing in case of traditional programming. So in case of traditional programming, we'll be having a problem statement. So for that problem statement, what we'll do, we'll think of some logic and we'll be writing that particular program. And also we'll be having some input. So we'll be passing this particular program and input to the machine, and this machine will be generating the output. So this we have seen it in normal traditional programming or whatever things that we have seen till now. All those things will work like this. All the C++ programs and all will work like this. Now let's see how machine learning will work. So machine learning will work little differently. So let's see that. So in machine learning, like we'll be having the machine, and to this particular machine, we'll be passing both input and also we'll be passing the output. Now this machine will observe the pattern between input and output, and it is like generating the program. Okay, so that is happening in case of machine learning. So let's take some example and see how traditional programming is different from machine learning. So like let's write a function with our logic. So there is a problem statement. So based on that problem statement, we are thinking of logic, and the logic that we came up with is 5x cube plus 9x square plus 100. So let's say this is our logic. Okay. So like based on the problem statement, we are writing this particular function. This we do it in traditional programming. Okay. But in case of machine learning, what will happen? We'll be having input that is X. So let's denote it with capital X. And also we'll be having output that is Y. So let's denote it with capital Y. So for every possible X1, there will be some possible Y1, right? So like that X2, there will be some Y2. So on like that, there will be point Xn, and for the Xn, there will be some output Yn. Okay. So like like that, we will be having both input. So this is our input and this is our output. And similarly here, this is our input and the corresponding output is Y2. And here Xn is our input and the corresponding output is Yn. So like that, we'll be having both inputs and outputs. So based on these inputs and outputs, the machine will be generating program. And what is our program? So the program for this particular input and output data is 5x cube plus 9x square plus 100. Okay. So how this will be done? This will be done by the machine by observing the pattern between x1 and y1. So all these inputs. Okay. So the data that we show to the model for the machine learning model, that we call it as training data. Okay. So here the data that we are seeing over here is training data. That is because we'll show this whole data to model, and the model will extract pattern and it will find out like this. Okay. This is the program that will be the output of this machine learning. Okay. So now let's move on to the next part. So now we have discussed about what is machine learning and what is how it is different from traditional programming, and also we have seen a little bit about deep learning. Okay. So let's see what are all the steps involved in some machine learning process. So the first and foremost step will be data collection. So what will be our first step? It is data collection. So we'll be having some problem statement. Based on that problem statement, like let's say there is some problem like price prediction. So this is some example problem. For this problem, our output is price, and what will be our input? Let's say if it is flat price, then the input can be area, number of bedrooms. There can be say many possible features like this. So we are thinking of two possible features like that. We need to think of all possible features in order to predict this particular price. And what we'll be doing, we'll be collecting data for all these columns or all these input features, and also we'll be collecting the price, that is our output. So like that, we'll collect both input and output, and then we'll be proceeding further. But nowadays we are having many data sets available in either Kaggle or GitHub. So in these websites, you can find datasets, but you are not able to find dataset for the application that you are working on. Then you need to collect data on your own. Okay. So you need to collect the data from legit source. Okay. Or you need to collect by yourself. And after collecting the data, there can be many problems within the collected data. So we have to clean that particular data that we are having. So first we need to collect the data, and we need to solve the problems within the data by doing some cleaning. So this we can call it as either data cleaning or data pre-processing as well. So in case of data pre-processing, we can do or we can handle missing values. So sometimes the values in the collected data might be missing. So those should be handled. And similarly, we can do some data engineering. So data engineering is like with the help of existing features, we can do some modifications and generate some new features, which will help us in predicting the output. Like that, there are several pre-processing techniques. We'll be going through few of these. Okay, so one by one. And after data cleaning or pre-processing, what will be our next step? We need to select ML algorithm for the problem. So whatever problem we are having for that specific problem, we need to select one machine learning algorithm. As I said, there are many machine learning algorithms available in the internet or in the market. So we need to select for some specific problem. Few algorithms will be working good. So in those, we need to select one. And after selecting that, then we need to start model training. And after training our model, we need to test our model or evaluate our model. And if it is working fine, then we'll be going for deployment, model deployment. This is the last step. Let's say if your model on evaluation, if your model is not working well, then what we'll do, we'll go back and change some things in the model and we need to train it again. Like that, this is some iterative process that will be keep on going on. Okay. So these are a few steps that are involved in any of the machine learning process. Okay. So I hope you guys understood everything till this point that we have discussed. And if you are having any kind of doubts, you can comment down in the comment section and we'll be discussing about what are the different types of machine learning algorithms. Those things we'll be discussing in the next video. That's it for this video and thank you everyone. Bye bye.